In high-power power supply design, magnetic saturation can cause inductor failure, drop system efficiency, or even damage components. That's why understanding an inductor's saturation current and thermal rise is key to stable and safe circuit design. Microtest's high-power inductor saturation and temperature rise test solution. The only solution in the industry with up to 640 amps of high current output and a wide frequency response from 100 Hz to 10 MHz. Helping you take your inductor design and efficiency to the next level. As shown here, power inductors are used in switch mode power supplies. By rapidly switching the MOSFET and combining passive components like inductors, diodes, and capacitors, the circuit converts high-speed switching waveforms into stable DC voltage. At this point, magnetic saturation becomes a key concern. When output current exceeds a certain threshold, the inductor core may saturate, causing a sharp drop in inductance. This directly impacts filtering and voltage regulation, leading to larger voltage ripple, overheating, or even ME issues. In power supply design, pulse currents and sudden overloads often cause magnetic saturation in inductors. When the core saturates, it can lead to inductance loss, current spikes, and system instability. That's why it's essential to accurately measure and verify the inductor's saturation current and temperature rise current. An inductor's performance isn't a static, single value. It changes with actual operating frequency and current. That's why, when testing inductors, you can't rely solely on the datasheet value at one fixed frequency. You need to perform frequency sweeps and apply DC bias current under real working conditions to truly understand how the inductor behaves in actual applications. When measuring inductors, using a standalone LCR meter isn't enough. Without applying DC bias current, the measured inductance is just a static value, taken under no load, non-operating conditions. And most LCR meters only measure at a single frequency, which means you can't see how the inductor actually behaves across different frequencies. To capture real performance, you need a high-precision impedance analyzer with a DC bias current source, so you can apply actual operating conditions and dynamically simulate the inductor's real-world behavior. To prevent magnetic saturation from affecting circuit design, inductor manufacturers specify Isat, or saturation current, in the datasheet. This value typically refers to the current level where inductance drops by 30%. Next, let's look at another key parameter related to inductor reliability: temperature rise current. IRMS is the maximum current an inductor can safely handle over time, under thermal equilibrium. Manufacturers typically define it as the current that causes the surface temperature to rise by 20 or 40 degrees Celsius. This temperature rise comes from DC resistance losses. As current flows through the winding, power loss generates heat, causing the inductor to warm up. And as temperature increases, so does resistance. This is due to copper's temperature coefficient, 0.00393. That means for every 1 degree Celsius rise, the DC resistance increases by about 0.393%. Higher temperature, higher resistance, faster heat buildup. By understanding this feedback loop, we can accurately calculate the IRMS for long-term operation. Now, let us introduce the Microtest Inductor High Current Saturation and Temperature Rise Characterization Solution, the DC Bias Current Source Test System. This system integrates an impedance analyzer with a DC bias current source, designed to verify saturation current and temperature rise current for inductors, magnetic cores, and coils. It's the only solution in the industry that supports up to 640 amps of output current, with high-frequency response from 100 Hz to 10 MHz. It can be configured as a benchtop or rack-mounted system. All test settings and measurements are controlled by the impedance analyzer, providing accurate, real-time data. In addition, Microtest offers both DIP-type and SMD-type test fixtures, allowing engineers to choose based on the inductor package. You can also add the optional PC-Link software for remote programming, test control, and data collection. Next, let's perform an actual measurement on a Vishay inductor using the Microtest DC bias current test system. In list mode, multiple DC bias current levels are set to measure inductance under different bias conditions. In sweep mode, the x-axis represents the applied DC bias current, and the y-axis shows the measured inductance. This allows engineers to precisely plot the inductor's saturation current curve. The system also displays the percentage drop in inductance, providing a more intuitive way to verify magnetic saturation. When it comes to temperature rise current analysis, Microtest bases its approach on how the DC resistance, or DCR, changes with temperature. This forms the foundation for their temperature rise current sweep analysis. As we all know, an inductance coil is made by winding copper wire. Copper has a temperature coefficient of about 3,930 parts per million per degree Celsius, or 3,930 parts per million per degree Celsius. In other words, for every 1 degree Celsius increase in temperature, the resistance of the copper wire increases by roughly 0.393%. Therefore, Microtest measures how the DC resistance of the inductor changes under different current levels. Using the relationship between DCR and copper's temperature coefficient, they derive the temperature rise characteristics of the inductor.
During measurement, based on the known specifications, such as temperature rise current, Irms, and the target temperature rise of the inductor, you can set the following parameters. Next, let's take a look at the actual test footage of the Microtest DC bias current test system. Actual measurement of the magnetic saturation current and temperature rise current of a Vishay inductor. Next, let's take a look at the actual test footage of the Microtest DC bias current test system. Here are the available model options of the Microtest DC bias current test system for different current output levels. Thank you for listening. If you have any questions or requests, please feel free to contact us. We're here to assist you as soon as possible.